Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Hi everyone. Our topic today is a periodic table. Now we focus on periodicity. As we know that the periodic table are arranged by increasing proton number. The positions of element in periodic table can be determined by using electronic configuration. As we can see from the slides now, we have a group from group 1 until group 18, period from period 1 until period 7, and a block S, P, D, and F. Now we discuss about the criteria for the groups, blocks, and period. Group element must have the same number of valence electrons. Group come from the group 1 until group 18. For the period, it must have the same principal quantum numbers. We have 7 different periods, start from period 1 until period 7. For the block now, we discuss about the S block. S block must come from group 1 and group 2 with the valence electronic configuration NS. For the P block, it comes from the group 13 until group 18 with the electronic configuration NS and P. And for the D block, elements come from the group 3 to group 12 with the electronic configuration N-1D and S. We can determine the positions of elements using electronic configurations. For example, for the S block, if valence electronic configuration NS, so it refers to S block. So the A here to give you a group, which is group 1 to group 2. And from the same electronic configuration, we also can solve for the period. So the period for this should be period N. Now we discuss about the P block. Valence electronic configuration NS and P to give you P block. How to solve for the group? It must be A plus B here and plus 10. So that 10 come from the transitions element. If we need to solve for the period, we can solve using the principal quantum number here, which is N. For the D block, if valence electronic configuration N-1 ND and S, it is D block. How to solve for the group? It must be A plus B. And period come from the principal quantum number, which is N. Now we try to solve the positions of element using magnesium X example. Magnesium with electronic configuration 1s2, 2s2, 2p6, and 3s2. So what is the strategy? Step number 1, we have to write the electronic configuration. For example, for magnesium, we get 1s2, 2s2, 2p6, and 3s2. So the outermost or the valence electronic configuration equal to 3s. So here is your 3s. So if 3s, we can solve for the block. For the S block, it must be NS. For the P block, it must be NS and P. And the D block, N-1 D and S. Magnesium, valence electronic configuration 3s2. So equal to for the S1. Means that magnesium is located at the S block. Now, we need to solve for the principal quantum number or the period. Because N equal to 3 means magnesium at period 3. And what is the number of valence electron? Here we get 2. The number of valence electron for the magnesium should be 2. As a conclusion, the outermost electronic configuration or the valence electronic configuration for magnesium is 3s2. Thus, magnesium is in period 3, group 2, and S block. Now, we go for the example. We have 3 examples there, which is lithiums, aluminiums, and vanadiums. So our objective now to solve for the blocks, group, and period. Before we start with this, we try to recall how to determine block. S block, the valence electronic configuration must be an S. P block must be an S and P. And for the D block, it must be N minus 1, D, and S. So, for lithium's electronic configuration is 1s2, 2s2. So this is the valence electronic configuration. So from here is equal to Ns. So means lithium from the S block. How about the group? Group can be solved from the number of electrons here. So it is group 1. So how about the period? Because this is N equal to 2, so the period should be period 2. Now we go to the next example, aluminium, with electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p1. We highlight the valence electronic configuration here, which obey Ns and P to give you P block here. So what is a group? For P block, the group comes from 2 plus 1 and plus 10 to give you group 13. How about the period? From the principal quantum number, which is N equal to 3. For the last one, we discuss about vanadiums. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. So we check the valence electronic configuration 3d3, 4s2, which obey this criteria to give you vanadium in a D block. How to solve for the group? Is from 3 plus 2 to give you group 5. And when we discuss about period, we must check the highest principal quantum number. From here, it is 4. So it comes from period 4. Now, we check all the answers from the given predictables down here. Lithium. This is your lithiums in positions in the group 1. So, correct. And period 2. Location, S block. Now, we go to second example, aluminium. We try to find aluminium here. This is your aluminium. Group 13, period 3, block P. And the last one, vanadium. Let's try to find vanadium here. Group 5, period 4, and it is from the D block. So we can confirm it now. Once we have the electronic configuration, we can solve for the block, group, and period.